Hey there, or something. He wouldn't even say our name. Yeah, he doesn't even know my name.
Actually, I do.
Okay.
Ari Selvi.
All right. You guys ready to go? All glued in? All right.
Yes.
Wait, I was right there.
All right, guys. Perfect. So the printer did not like me this morning. So some of you have some kind of not great writing at the top. All that says is every term must be a fraction. That's what it says. So go and fill that in if you need to. Every term must be a fraction. If there's no denominator, what can I put under a whole number to make it a fraction? 1. I'm going to find my LCD to make equivalent fractions, cross out my denominators, and solve. All right? So we're going to make it nice and easy. If I look at number 1, right, what are the denominators I have in number 1? I've got 2 and I've got 4. Oops, there it is. Now this is a nice easy one. Everybody, what's my LCD going to be here? Oh, maybe it's not so easy. Well, if I wrote out the factors or the multiples here, not factors, the multiples, 2, 4, 6, 8, 4, 8, 12, 16. Is there any multiple that those two have in common? Precious, what do they got? 4. The easiest way in this situation for us to find the LCD is to ask ourselves, is my biggest denominator a multiple of each of my smaller denominators? I'm going to say that again, and I'm going to make it easier. Are my smaller denominators factors of my largest denominator? So, if I notice that 2 goes into 4 evenly, then the largest denominator is my LCD. My LCD here is 4. All right, that's the first thing we got to do is find the LCD. Some of us can do it in our heads, which is great. Some of us might need to write out the multiples, which is fine. Now that I know what my LCD is, I need to make all of these fractions turn into fractions with a base of 4, the denominator of 4. How many total terms do I have here in number 1?
3.
I got 3 of them. This here is a denominator of 2. What can I multiply 2 by that's going to give me a 4 on the bottom? 2. Now, can I just multiply the bottom of my fraction? No, I got to multiply the top by the same number, because what is 2 over 2 equal to? It's just equal to 1. If I multiply something by 1, does that change what the number is? No, it may change how it looks, but it doesn't change what it is, right? X over 4. Do I need to do anything with x over 4? No. It already has my LCD as the denominator. What can I multiply 1/2 by? 2 over 2 again. All right. I'm going to do a line under it. What's negative 9 times 2? Negative 18 over, like we said, we want the 4, plus x over 4 equals, what's 1 times 2? 2 over 4. So you see 1/2 and 2/4, those are the same thing. All I did was selectively magnify a couple of my terms to get them all on the same scale. All right? Now that all my terms have the same denominator, what can I do with those denominators? Knock them out or cancel them out. So that I'm left with negative 18 plus x equals 2. I've successfully broken or busted my fractions all my terms are now either whole numbers or whole variable terms. No fractions involved. All right, am I done? No. How can I get x all by itself now? Levi, what do I got to do?
Add 18 both sides.
Add 18 to both sides. Capiche, what do I get when I add 18 to the right-hand side? X equals what? Perfect. X equals 20. I'm going to box that up. There's my answer. Once again, the syntax here, or the structure, is very important. All my terms are nicely in line with each other. Every time I do something, I'm putting a horizontal line under my equation to show that I've got a new version of that equation below it. When I'm doing my inverse operations, I'm putting them under the terms I can combine them with. These are all really important things when we're showing our work. What questions can I answer about number 1? Feeling pretty good? It's hard to tell. Yeah, Precious. What's that? Great question. Why did I just cross out all these 4s? Well, if every term is out of the same denominator, technically what I did, that I kind of should have said, is I took this whole equation and I multiplied the whole thing by 4, right? That allows me to cancel out this 4 with this 4, this 4 with this 4, and this 4 with this 4. So mathematically what I'm doing is I'm multiplying the entire equation by the denominator to cancel out the denominator. But in a more like colloquial sense, if all my terms have the same number on the bottom, I can just get rid of them. Does that make sense? Yeah, great question. Really good question. But yes, mathematically that is what we're doing. Now if I look over to number 2, this one might be a little bit trickier. What are my denominators here in number 2? What are my 3 denominators that I have? 3, 6, and 10. All right. Now right away I look at that and go, 3 goes into 6, but 3 doesn't go into 10, and 6 doesn't go into 10 either. So the easiest way to do this is I'm going to take my biggest number and I'm going to write out the multiples of my biggest number. 10, 20, 30. Does 3 go into 20?
No.
No. Does 3 go into 30?
Yes.
Yes. Does 6 go into 20?
No.
Does 6 go into 30? Yes. So what's my LCD going to be? 30. Right? If I wrote out my multiples for each of these numbers, 3, it would take me forever to get to 30. 3, 6, 9, 12, 15, 18, 21. I still haven't gotten there. Right? So save us some time. Just focus on the largest denominator and then kind of guess and check your smaller denominators against those multiples. Does that kind of make sense? Okay. So I need all my terms to have a 30 on the bottom. None of them currently do, so I've got to change each of these terms. Now what I multiply them by is still just 1, but they're going to be different. So for this first term, 3 over 10x, what can I multiply 10 by that's going to give me that 30 on the bottom? 3. But I got to multiply it by the whole fraction, 3 over 3. Everybody with me?
Yeah.
All right. If I have a 3, what can I multiply 3 by to give me 30? 10. But I can't just multiply the bottom. I got to multiply the whole fraction by 10 over 10. Finally, what can I multiply 6 by? 5 over 5. So again, I'm stretching out each of these terms, or I'm magnifying each of these terms at different degrees so that they're all on the same page. You guys want to make your lives a little bit easier?
Yeah.
Okay. You notice how in this step we rewrote everything just to get rid of the denominators?
Yes.
Let's just get rid of all the denominators. I know they're all going to be 30. That's why I did what I did, right? So I don't need to rewrite them just to cancel them to rewrite it again. All we're going to focus on is everything across the top of my equation. So what is 3 times 3x? 9x. What is what is negative 4 times 10? Negative 40. And what is 1 times 5? 5. So look at that. We didn't have to rewrite the fractions at all. We skipped this whole step right here. Give me a thumbs up if you see how I did that. Okay. Now, if you want to rewrite it, that's fine. I support you. But if we want to make our lives a little easier, I know that these are all going to give me 30, and I know that my next step is going to be to cross them out. So let's just cut out the middleman and cross them out right now. All right? What can I do from here to get x all by itself? No? Janelle? Perfect. Add 40 to both sides. What is 5 plus 40? 45. What's my last step going to be? Divide by 9. How many times does 9 go into 45? 5 times. So x is equal to 5. Dang. I think I printed this wrong. Any questions on number 2? Okay, we're going to do number 3. We're going to do number 4. And then I'm going to let you do 3, 5, 6 on your own just for a little bit of practice. All right, so look at number 4. What's the very first thing I want to do here in number 4? Find the least common denominator. Even before that, what do I need to do? Connie? Separate the sides. Good. Absolutely. What else do I need to do here? You're absolutely right. We separate the sides. Oscar, what do we got to do?
Make them into a fraction.
Turn my whole number into a fraction. If I'm finding the LCD, I need all my terms to be fractions. What denominator can I assign this negative to, Robert? A 1. Does that change anything about us finding the LCD? No, because 1 is a multiple, or 1 has every number as a multiple. But if I don't put this over 1, every time, even in Math 1, someone will forget to multiply this term. So if we put a 1 under it, that's going to tell my brain, this has got to be multiplied by something to get my LCD. All right? So I've got 4 and 6. 4 does not go into 6, so I'm going to list out my multiples here. 12. Oh, 4 goes into 12. My LCD is 12. Right? So my first term has a 1. What can I multiply 1 by to give me 12? 12. Bless you.
Thank you.
Again, if I don't put that 1 under there, it is inevitable that we will forget. Maybe not now, maybe not tomorrow, maybe on the test. And that's when we really don't want to forget. What can I multiply 6 by to give me 12? 2. And what about 4? Multiply by 3. All 3 of my terms now are going to have what as a denominator? 12. 12 times 1, 6 times 2, 4 times 3. Away they go, leaving me with, what's 12 times negative 2? Negative 24. What's negative 5 times 2? Negative 10. And negative 1 times 3? Negative 3. All right? What can I do from here to get b all by itself? It's the first thing I want to do. Do I want to divide both sides by negative 10 first? Precious, what do I do? Add 3. What's negative 24 plus 3? Negative 21. What do I want to do now? Divide by negative 10. What's a negative divided by a negative always going to give me? A positive. Can I simplify 21 over 10? Nope. Should I turn it into a mixed number? 2 and 1 10. A mixed number? No, definitely not. I will cry if I see a mixed number. If you turn it into a decimal, it would be what? 2.1? It's technically, you're fine, but I would rather you keep it like this, 21 over 10. It would be 2.1, right? Yeah. All right? Sound good? Perfect. Give 3, 5, and 6 a try. You're more than welcome to work together, or if you want to just knock it out by yourself, totally fine. And then we'll take a look at the answers here in a couple minutes. All right? But I want you to give it a try first. Fours, twos. This is B. 10D. Equals 5. Yeah. Cool. This one is it. This one, we gotta get it up to 18, right? So 9 equals negative 10 plus 12. 9 equals negative 10, so 12 should be 19 over 12. Yep, good job.
So, wait, what is it? Freshman handshake. That's so simple. Sounds like you feel like companies right next to there. If you have a good thing, your favorite guy, you sit next to me.
Yeah.
It's like you can
Yeah, you can cross out all the letters. Minus.
Yeah, I got the same answer.
You guys like the new H3 schedule?
I got the same answer.
I'm like a kid. It's like all
Hilarious.
Nah, but like for here,
don't sorry.
the theme is,
Uh-huh.
and I didn't learn one thing. I didn't learn one thing. Say it to us. Say it to us.
It's okay. So this is exactly what I said, right? It's all right. This is why we're doing practice.
But in this, I learned.
All right.
Actually learned.
Real quick, let's take a look so we could breeze through this. The front page of the worksheet is like much easier than this. So if this was easy, then you'll be fine. Okay? Number 3, what's my LCD in number 3? 6. So I'm going to leave my first term alone. I'm going to multiply this by 2 over 2. I'm going to multiply this by 3 over 3. 6's all go away. 5 is equal to 4b minus 3. Add 3 to both sides. 8 is equal to 4b. Divide both sides by 4. Flip it around. B is equal to 2. Give me a thumbs up. You got 2 for number 3. Good. Most of us did. I was walking around and taking a look. All right. Number 5. What's my LCD in number 5? 4. That's right. So I'm going to leave my 1/4 alone. I'm going to hit this with a 2 over 2. Boom, boom. 1, 10d, negative 1 plus 10d. I'm going to add 1 to both sides. I get 10d equals 2. Divide both sides by 10. And then what does that simplify to? 1/5. Give me a thumbs up. You got 1/5.
Isn't it negative 2?
I'm surprised you guys let me go that far without anyone stopping me. That shows me you guys aren't listening. What did I do wrong? Isaac, what did I do wrong? Okay, listen up, because I saw this when I was walking around. Isaac, one more time. What did I not do?
You didn't turn the whole number into a fraction.
I didn't turn that negative 1 into a fraction, which means when I went multiplying, I forgot to multiply it, right? I saw some people with 1 over 5 as an answer, though, right? This negative 1 should be a negative 4. Then I should be adding a 4, and this should be a 5. So when I divide 5 over 10, I get 1/2. All right, this is why I wanted us to do some practice in our notes before we get to our worksheet, to alert you of the dangers that may lie ahead. All right. Number 6, what's my LCD here? 18. Good. I can see, hey, 2 doesn't go into 9. Well, what's the next multiple after 9? 18. 2 goes into 18. 3 goes into 18. So I'm going to multiply this by 9 over 9, 2 over 2, 6 over 6. Cross them out. Boom. 9 equals negative 10 plus 12n. Add my 10, add my 10. 19 equals, that's a weird way of writing that, 12n. What does 19 over 12 simplify to?
19 over 12.
19 over 12. Give me a thumbs up, you got 19 over 12. Misty did. Vivian did. Levi, Benjamin, Oscar did. Good.